Welcome to the Pythagorean Theorem. Today's objectives are to use the Pythagorean Theorem and its converse to solve problems, and to use Pythagorean inequalities to classify triangles. The Pythagorean Theorem is used to solve the side lengths of any right triangle. So the triangle has to be a right triangle to use the Pythagorean Theorem. So the Pythagorean Theorem tells us that the sum of the legs squared equals the hypotenuse squared, or more casually known as a squared plus b squared equals c squared. Now let's use the Pythagorean theorem to help us find the value of x. When we get our answer, we want our answer to be in simplest radical form. In example A, 6 and 4 are the legs of the triangle, and x is our hypotenuse. So the equation is set up as so: 6 squared plus 4 squared equals x squared. Now 6 squared is 36. 4 squared is 16. So we're left with 52 equals x squared. But this answer isn't in simplest radical form, so we have to take the square root of each side. When we do that, we're left with x equals the square root of 52. But that isn't simplified. We want to break that down. So we know the square root of 4 times the square root of 13 equals the square root of 52. And the square root of 4 is 2. And we can't break down 13 anymore. That's our answer in simplest radical form. So now let's talk about Pythagorean triples. A Pythagorean triple is a set of three non-zero whole numbers a, b, c such that a squared plus b squared equals c squared. So we call that a Pythagorean triple. So it's a set of numbers that fit the Pythagorean theorem, but they have to be non-zero whole numbers. So for example, I can try one of these out. 3, 4, and 5 are Pythagorean triple because 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25, and 25 equals 25. So these four sets are all Pythagorean triples. Let's look at this picture and see if we can identify a Pythagorean triple. So it wants to find the missing side length and tell if the side lengths form a Pythagorean triple. So this is a right triangle, so I can use the Pythagorean theorem to solve for x. So I have 9 squared plus 15 squared equals, and I'm going to make my hypotenuse x, since I don't know that. Alright, well I know that 9 squared is 81, and 15 squared is 225. So I add these two numbers up, and I have 306 equals x squared. Now, if I solve for x squared here and take the square root of each side, what I'm going to be left with is 3 times the square root of 34 equals x. So this is my hypotenuse for this triangle. Now, it's not a whole non-zero number, so therefore this is not a Pythagorean triple. So So once again, this is not a Pythagorean triple because 3 times the square root of 34 is not a whole number. Now, when looking at triangles, we can use the side lengths to classify a triangle as acute or obtuse. So we can use side lengths to classify triangles as acute or obtuse. Now, for our example right here, by looking at it, we can probably estimate that this is going to be an obtuse triangle. But why is that? Well, we can use the Pythagorean Inequality Theorem to help us prove that. So, if in a triangle c squared is greater than a squared plus b squared, then the triangle is going to be obtuse. And in this example here, if c squared is less than a squared plus b squared, then this triangle is acute. And that makes sense because if these are bigger, then this has to be the biggest angle. And these angles can't be equal to the other two sides because that would just make it a right triangle. So we're talking about classifying triangles as obtuse or acute. Now let's use the Pythagorean Inequality Theorem to help us determine if A, the measures can be the side lengths of a triangle, and if so, classify the triangle as acute, obtuse, or right. So there's two parts to this. So this is part A, and this is part B. So in part A, we're trying to determine, can this be a triangle? Well, we have to use the triangle inequality theorem. So we add up two sides and see if they're bigger than the other one. So 8 plus 11 equals 19, which is greater than 13, so that's good. 11 plus 13 equals 24, which is greater than 8. And 8 plus 13 equals 21, which is greater than 11. So we're good. This can be a triangle. Now part B says to classify the triangle. So to do that, I want to set up my equation of c squared, a squared, plus b squared. Now I'm leaving this part out because I'm waiting to plug these numbers in to determine whether c squared is greater or to determine whether c squared is less than. So to pick c, c is always going to be your biggest. So in part A, 13 is the biggest. So I'm saying 13 squared, and then I don't know whether it's less than, equal to, or greater than. And then A and B can be either of the other two. So it can be 11 and 8 or 8 or 11, doesn't matter. It's addition. So we have 8 squared plus 11 squared. So now let me just square all of these numbers. I know 13 squared is 169. I know 8 squared is 64. And 11 squared is 121. Now if I add 64 and 121, I get 185. So 169 is less than 185. Therefore, this triangle is an acute triangle. So the first step was to figure out whether it can be a triangle, and then use the Pythagorean Inequality Theorem to determine whether it was acute, obtuse, or right. So for part B, we want to do the same. So first, let's figure out whether it can be a triangle. So we have 5.8 plus 9.3. And this equals 15.1. Now, 15.1 isn't bigger than 15.6. So 15.1 is less than 15.6. Therefore, this is not a triangle. So we don't even have to bother whether to classify it, because technically it can't be classified as a triangle. And that is the end of our video. Thank you. Take care.